Hi there, and welcome to Lesson 11 of Algebra 2 Remote Learning with Hotard. Today, dear people, you will experience the thrilling conclusion to our lesson on 7.4, Adding and Subtracting Rational Expressions. There will be suspense, drama, and like all algebra lessons, one or two minor characters may die from this. But stay tuned to the end for the thrilling conclusion of adding and subtracting rational expressions. Last time, we were adding and subtracting rational expressions with monomial denominators. Today, we will be looking at what happens when the denominators are not monomials. What happens if you have something plus something or something minus something in the denominator. Dum dum dum. Okay, so the idea here in these problems, if you look at the denominator, we want to find our least common denominator. Just like adding fractions, you need common denominator. To find the LCD, you want to try to factor what's on bottom first. A lot of times you can't do that. So in this first example, there's no greatest common factor. There's no x squared. There is nothing to factor on the bottom. So to find my LCD, when I have two binomials like this, or in example 2, when I have a monomial and a binomial like this that cannot be factored, you just put them together. The first example, my LCD, my least common denominator, just put these together. It'd be x minus 5 times x plus 4. That would be my common denominator. Don't try to find a least common multiple of 5 and 4. All right, I need to have a common denominator to where I can multiply this one times something to get to this. So I need to change both of these fractions into something over x minus 5, x plus 4 for both of them. So you're just multiplying by whatever's missing. This first fraction has an x minus 5. It does not have the x plus 4. So I would need to multiply that first fraction by x plus 4. So I'd have to multiply each of these terms by each of these terms. So 3x times x would give me 3x squared. 3x times 4 would be 12x. And then 2 times x would be 2x. So we can go ahead and combine those. 12x plus 2x would give us plus 14x. And then 2 times 4 would be plus 8. Just multiplying each of these terms by each of these terms. Now, over in the second fraction, I need to get to x minus 5x plus 4. I already have the x plus 4. What's missing? X minus 5. So I would need to multiply the second fraction times x minus 5. So again, I'd have to FOIL this. I'd have to multiply each of these terms by each of these terms. X times x will give me x squared. X times negative 5 is negative 5x. Negative 1 times x, negative 1x. And then I can combine those like terms. And then negative 1 times negative 5 would be positive 5. And I could tell negative 5x and negative x is going to give me negative 6. I could have just put negative 6x right there. I'll just write it above it. All right, and then now I have my common denominator. Let's just add it all together, combine our like terms. So our answer, we have 3x squared plus x squared would give us 4x squared. We have 14x minus 6x. That will give us plus 8x. And then 8 plus 5 is plus 13. All over that denominator, x minus 5, x plus 4. So again, hardest part of this whole concept is just make sure you're getting the correct common denominator. Two binomials like this, just put them together. All right, make x minus 5, x plus 4, multiply by whatever's missing. Second example, similar problem. I have a monomial and a binomial, nothing that can be factored. So I'm just going to put these things together. My LCD, least common denominator, is 5x times x minus 3. So I need to change both fractions into something over 5x parentheses x minus 3. So now I'm just going to go through and multiply by whatever's missing. First fraction has the 5x, does not have x minus 3. So let's multiply that. So again, I'm going to have to FOIL that. X times x is x squared. X times negative 3 is negative 3x. And then 1 times x is 1x. Let's combine them. Negative 3x plus 1x, negative 2x. And then 1 times negative 3, negative 3. Now, second fraction, we had the x minus 3 already. What was missing from it? 5x. So I'm going to multiply the second fraction times 5x. So up here, I'm just distributing 5x to each of these terms. 4x times 5x. Is that 20x? It's 20x squared. And then 2 times 5x plus 10x. Now I have my common denominator. We can work out the top. But remember, this one's subtraction. So what's that mean for this stuff over here? It means I'm subtracting each of these away. I'm subtracting 20x squared. I'm subtracting 10x. So when I work this out, my answer, I've got x squared minus 20x squared, going to give me negative 19x squared. I have negative 2x minus 10x, going to be negative 12x. And then negative 3, nothing to combine with that. So just leave that as a negative 3. All right, over that denominator, 5x, parentheses, x minus 3. There's my answer. So again, if you have a monomial and a binomial, or if you have two binomials in your denominator, just put them together to get your least common denominator. Now, two other problems. Let's make them a little bit more complicated. Now this time, I have polynomials here on the bottom. Look on the bottom first. All right, and they're not already the same denominator. I need to try to factor these. All right, you always want to try to factor the bottom as your first step. In the first two problems, we couldn't do that, but now we can. So in this first problem, I need two numbers that multiply to give me negative 6 and add to give me negative 1. That's going to be negative 3, positive 2. X minus 3, x plus 2. That's what the denominator of the first fraction factors into. Second fraction, look at the bottom. This time, I need, just draw a line here so I don't mix them up. I need to find two numbers that multiply to give me positive 2, add to give me positive 3. Before you say, no, that can't be done, remember 1 times anything gives you that number. 1 times 2 gives me 2, 1 plus 2 gives me 3. So x plus 2, x plus 1. So these are our factors. Now, for our LCD, I'm just going to write it up here, least common denominator. You need to list any factor that shows up has to be in your LCD. So x minus 3 has to be part of that common denominator. Have x plus 2. X plus 2 is in both of them. I only need to use it once. And then x plus 1. This whole thing will be my common denominator for this problem. All right, and some of you are thinking, wait, that whole long thing? Yes, that whole long thing. So both of these fractions need to have all three things in the denominator. X minus 3, x plus 2, x plus 1 in both fractions. So now, go through and multiply each fraction by what was missing. The first fraction has x minus 3. It has x plus 2. What's missing from it? X plus 1. That's what I had to multiply here. So 4x times x plus 1 is going to give me 4x squared plus what? Plus 4x. Second fraction. Look at the factors. We had x plus 2. We had x plus 1. We need this. What's missing from it? X minus 3. So let's multiply by x minus 3. So 5, distribute that to x minus 3, going to be plus 5x minus 15. Now we have our common denominator. The hard part's done. Now it's just combining like terms. And so my final answer, I have 4x squared, 4x plus 5x will give me plus 9x, and then I have minus 15 all over that big long denominator. X minus 3, x plus 2, x plus 1. All right, that one was a little more complicated. Now, last problem. We want to subtract these fractions. We do not have common denominator yet. So again, the first thing you want to do, before you pick out your common denominator, what's the first thing you should do on bottom? Factor it. And what's the first thing you should look for when you're factoring? Greatest common factor. GCF of the first one is 5. I could divide out 5. That's going to leave me with x squared minus 9. Now I could factor that some more. Middle number is 0, remember. So what numbers multiply to give me negative 9 and add to give me 0? 3 and negative 3. So this first denominator is really 5 x plus 3, and x minus 3. Let me just draw a line here so I don't mix my work up for the two problems. All right, that's the first denominator. Second denominator. This one also has a GCF. It's not just 5 this time. It's 5x. 5x, and that's going to leave me with x minus 15. Now, there is no x squared, so I can't split that up anymore. Not x minus 15. X minus 3. 15 divided by 5. That's a 3. All right, so now I factored it. I'm ready to pick out my least common denominator. So let's just go through and list what all we have. First of all, let's look at the monomial parts. We have a 5 and a 5x. So just like yesterday, when you have 5 and 5x in your two fractions, what's your common denominator? It's 5x. You have to list everything that shows up in the monomials at least once. 5x. Now look at the binomials that are left. X plus 3, and then both of them have an x minus 3. So I need to include both of those. 5x, x plus 3, x minus 3. That is my LCD, my least common denominator. So let's make both of these fractions over that. 5x, x plus 3, x minus 3. So again, I'm just going to go through and multiply each of these fractions by whatever is missing. So look, when we factor the bottom of the first one, we had x minus 3, we have x plus 3, we have the 5. What's the only thing missing? X. I just need to multiply first fraction times x. So that's going to become 3x squared. All right, second fraction. After I factored it, I have 5x, I have x minus 3. It's missing what? X plus 3. Let's multiply that one times x plus 3. So that's going to be, let's see, so 2x times x plus 3 is going to be 2x squared plus 6x. Now remember, it's subtraction, so this minus goes to both of these. I'm subtracting away 2x squared, I'm subtracting away 6x. So when I combine like terms, 3x squared minus 2x squared is going to give me 1x squared, and then minus 6x all over. That's going to be 5x, x plus 3, x minus 3. Now this is correct, but there's actually something we could do to simplify it. Because you notice, unlike these other problems, this one on top, there is a greatest common factor here I could factor out. What's the GCF? They all have an x, all right? And I'm seeing I also have an x on bottom, so I can simplify this. I can factor out x. That's going to leave me with x minus 6 on top over that big mess on bottom, 5x, x plus 3, x minus 3. I can divide out this x right here. I can cancel them out just to simplify it a little bit. So my answer is x minus 6 over 5, x plus 3, x minus 3. Now, some of y'all are thinking, do I have to do that? Well, what if I just had stopped right here? This is not wrong. This is the correct answer. However, if this had been a multiple choice question, like if this had been an ACT problem, this would not be an answer choice. All right? They would expect you to be able to factor that, simplify it if possible. All right? It's not possible in every problem, but in this particular one it was. Okay, so finding common denominator, remember factor the bottom first if you can. List each individual factor that shows up in your common denominator. Multiply the fractions by whatever is missing. So y'all, I posted a study guide on Moodle that goes along with this. It has problems just like these as well as problems from yesterday. Try those out. Check your answers on my key. Email me if you have any questions. Good luck. Thank you for sticking with me to the end of this exciting conclusion of adding and subtracting rational expressions. Until next time, this is Hotard signing out.